Hello students. Welcome back to my chemistry channel. Today, I have come up with a new topic from electrochemistry of class 12th, variation of variation variation of molar conductivity, molar conductivity of strong electrolytes, electrolytes and weak electrolytes, weak electrolyte solution upon dilution. Variation of molar conductivity of strong electrolytes and weak electrolyte solutions upon dilution. This is the most important topic of electrochemistry. And before going to discuss about this variation of molar conductivity of strong electrolytes and weak electrolytes, first of all, let me tell about what is molar conductivity. The molar conductivity symbol we can write lambda m. Lambda m units we write for this molar conductivity are Siemens centimeter square per mole or Siemens meter square per mole we write. First of all, what is meant by molar conductivity? If you look into this molar conductivity term, conductivity is nothing but conductance of 1 mole of electrolyte solution. Conductance of 1 mole of electrolyte solution per 1 liter volume of solution, 1 liter volume of solution separated by the distance of electrodes. Which electrodes? Platinum electrodes of length. If you take 1 centimeter or 1 meter, 1 centimeter, and area of cross section of electrodes A, which can be said meter square, is called of the solution is called molar conductivity. So lambda m, we can write the symbol. Simple. So molar conductivity, as the name itself indicate, molar means so 1 mole of electrolyte, 1 volume of solution per 1 volume of solution. The number of ions present 1 mole of electrolyte per volume means in 1 liter. So how many ions will conduct electricity is said to be molar conductivity. Whereas conductivity is nothing but reciprocal of resistivity, conductivity, or conductance of ions per unit volume unit value is called conductivity. Conductivity, we say. And if you specify 1 mole of with 1 mole of electrolyte solution, 1 mole of electrolyte solution per volume of solution, 1 liter volume of solution, 1 liter volume of solution is said to be molar conductivity. Molar conductivity, we say molar conductivity, we can write. Okay. So now, what is the formula we can write for the molar conductivity? Formula for molar conductivity. The molar conductivity symbol already I mentioned, lambda m is equal to conductivity upon the concentration of solution. So as you know that concentration of the solution, concentration K is conductivity into 1000 means 100,000 ml upon C, we can write. So K upon C is the molar conductivity. This is the molar conductivity formula we write. Molar conductivity is the formula we can write. So now the molar conductivity. So here we have to talk about variation of molar conductivity. Variation of molar conductivity of strong electrolytes and weak electrolytes, upon dilution. So first of all, let me explain about how the molar conductivity changes with a strong electrolyte. So molar conductivity, if you take 1 volume of solution of strong electrolyte, in this the number of ions are present. How many ions are present in this? 1 mole of electrolyte, 1 mole of electrolyte per 1 liter volume. So ions number is fixed. So mostly strong electrolyte whose alpha is equal to nearly 1 means, so degree of dissociation is more. Number of ions that contribute electricity are more per fixed volume of the solution, so will be high in case of strong electrolyte, we say. Then molar conductivity will be higher. The molar conductivity will be higher in this case. And when we add excess amount of solvent, if we add solvent like water, if you add, which is called dilution, if we add to this same solution, electrolyte solution, whose number of ions are fixed, 1 mole, then if we add more excess amount of water, it is said to be dilution we call. So then the volume of solution increases, but number of ions are same. And upon dilution, so free mobility of ions increases, free movement. So mobility of increases, then molar conductivity also increases upon dilution. So we can discuss in detail about so how molar conductivity increases. So increases with a strong electrolyte. and upon dilution, how it molar conductivity increases. We can see by. So now I'm going to relating the molar conductivity versus the concentration of electrolyte. Here I'm plotting the graph. So I'm taking the graph. So and I'm plotting the graph, the square of the concentration of electrolyte solution and concentration. So 0, 0 0.2, 0 0.4, 0 0.6 concentration is taken. Concentration of the electrolyte taken on the x-axis. So and dilution, the direction of dilution towards decreasing of the concentration of the electrolyte. Now the molar conductivity is taken Siemens centimeter square or per ml. Molar conductivity is taken on y-axis. Y-axis molar conductivity. This is 400. This is 800. Molar conductivity taken on this y-axis. If you plot the graph between molar conductivity and molar conductivity versus the square of the concentration, if you plot the graph, so for a strong electrolyte, potassium chloride or sodium chloride electrolyte, if you take in the water, so how will be the graph? We can get the graph will be straight line. That means upon the dilution, so of the dilution, so and if you plot the graph between the square of the concentration of the electrolyte versus means strong electrolyte, for example, potassium chloride, if you take potassium chloride, here I'm taking potassium chloride. So the graph we can get is straight line we get. So that means for the strong electrolyte upon dilution, the molar conductivity increases. So already I mentioned the reason due to the free movement of fixed number of ions for increasing of the volume. So molar conductivity increases and shows the straight line. But what as the see, look at the graph here, and so concentration upon dilution, concentration decreases. Concentration at one particular zero concentration upon infinite dilution, the straight line will be intercepting here, intercepting. That intercepting point we say limiting molar conductivity. Limiting molar conductivity we can write. So limiting and this intercepting point, at this point if you write the slope is equal to minus a. That means here for the strong electrolyte upon dilution, the molar conductivity increases with the decreasing of concentration of the electrolyte solution. Then we can write the formula. Molar conductivity is equal to limiting molar conductivity minus A is the constant, and square of the concentration. We are plotting the graph between square of the concentration. Now the concentration of the electrolyte decreases upon dilution. The molar conductivity is increasing. Molar conductivity is increasing. So, and it will be intercepting at the point, that intercepting point. So there if you plot the graph, and that slope will be equal to minus a constant. So which is said to be what we call means the Kohlrausch scientist constant or coefficient also we say. And in case of strong electrolytes, the molar conductivity upon dilution, increases with the decreasing of concentration because the number of ions are fixed and the volume increases, and it will be intercepting at the on the y-axis. So that point what we call means limiting, that point what we call means limiting molar conductivity of strong electrolyte we say. And if you take weak electrolyte like acetic acid CH3 COOH, weak electrolyte, 1 molar weak electrolyte in the water, it will form the solution. Weak electrolyte, if you plot the graph between the square of concentration of the weak electrolyte and with the molar conductivity, if you plot the graph, then upon dilution, the molar conductivity, look at this, how the graph line we get for weak electrolyte. So upon dilution, so the molar conductivity increases, and finally it will increases more. And but it doesn't intercept the y-axis. So we can see the steep line rising. So for the acetic acid CH3 COOH, and so it is not intercepting the y-axis, but it is increasing more for the decreasing of the concentration of the weak electrolyte solution upon dilution. So why this is happening? So why it is happening? Why it is not intercepting the y-axis? Why it is steep line? So it is producing, and so here we cannot intercept this point, but we can. So here the limiting molar conductivity. So limiting molar conductivity at infinite dilution will be, so infinite we can get. So here that is called infinite dilution, and the limiting molar conductivity. So we can get, but here for the weak electrolyte it is not intercepting. So what could be the reason? What could be the reason for this? If you observe the weak electrolyte, so whose alpha value? Weak electrolyte alpha value. So for the weak electrolyte, so like acetic acid. So acetic acid degree of dissociation will be CH3 COO minus plus hydronium ion in the water H2O. So degree of dissociation almost all alpha value equal to how much? 0.2 or 0.3 maximum. That means the number of ions we get only 20% of ions it can produce, and the rest of the percentage will be 80% will be molecules in the solution. So when we add water upon dilution, so alpha value increases from 0.2 to 0.8. The degree of degree of dissociation increases. When the degree of dissociation increases upon dilution with increasing the volume, so the conductivity, molar conductivity increases. Molar conductivity increases because increasing of degree of dissociation. In case of strong electrolyte, this is not happening. Already alpha value equal to nearly 1. But in case of the weak electrolyte, since alpha value equal to 0.2, so 0.2 upon dilution, it increases 0.8 or more than 0.8. Since increasing of degree of dissociation, weak electrolyte molar conductivity increases steeply, but at that when the concentration reaches 0, then that infinite molar conductivity is said to be, or limiting molar conductivity we call. So in case of weak electrolyte, upon dilution, the molar conductivity increases, and when the concentration reaches to the 0, of the solution of the electrolyte solution, and it will reach the limiting molar conductivity. That means the limiting molar conductivity is obtained at infinite dilution. Infinite dilution method. So simply from this, what I want to say from this, molar conductivity with the strong electrolyte, so upon dilution increases with decreasing of concentration, with decrease of concentration of electrolyte. And similarly, the molar conductivity of weak electrolyte upon dilution decreasing of concentration, increasing molar conductivity. And at C equal to 0, molar conductivity is said to be limiting molar conductivity. Limiting molar conductivity, we write.